Thank you very much. I realize I am the last standing between you and the coffee break, so I will try to be brief and to the point. As it was reminded by Gunnar earlier before, if we don't manage to mitigate emissions from the carbon sector, from the carbon emissions from the different sectors of our economy, then we will most likely achieve by the end of the century a temperature level of 5 degrees or more. If, on the other hand, we want to stay within the 2-degree target or less, then we need to be into the green or yellow pathways that you see here, pick our global emissions within the next 10 years or so, and then gradually bring them down to zero by the end of the century. This is, of course, a great challenge, and it is a call for urgency in terms of reducing emissions from our economy. And this is in contrast from the historical trends that we see regarding emissions from the transport sector, which are steadily increasing, and more than 70% of those come from the road transport. And without the implementation of significant mitigation actions, transport emissions will increase at a faster rate than emissions of any other sector. We therefore have a big challenge here to decarbonize the transport system. And we are not dealing with a system that is static. We need to consider dynamics of the future, where transportation demand is predicted to further increase, especially in developing countries. If you take the example of Asia here, the demand for transport can increase up to 3 times by 2050 from the level that we have in 2010. Why this is occurring? Because we have a large share of the population who is transitioning from an agrarian society to an industrialized society. And there is a strong link between CO2 emissions from the transport sector and GDP growth. The real challenge is therefore to manage to decouple transport demand from GDP growth. And this is something that we see is to some extent occurring in industrialized society in Europe and in North America, because you can see the lines here tends to flatten after a certain level of GDP. So it is something that can, in theory, be achieved also at lower GDP level. And if we want to mitigate emissions from the transport sector, we need to have clear in mind what are the different components that are contributing to emissions from the transport sector. The last report from the IPCC is grouping 4 main factors that contribute to emissions from the transport sector. System infrastructure and modal choice, like, for instance, roads, network, railways, airports, and the preference of choosing one transportation mode over the other according to different types of criteria. Fuel carbon intensity, which is the use of biofuels or electric cars instead of conventional gasoline and diesel. Energy intensity, use more efficient transportation means. And activity. Activity which is connected to behaviors, to population. It's the society dimension here of the system. And in my presentation, I will mostly focus now on fuel carbon intensity and activity. This is an example of how the transportation system can evolve under a 2-degree target. This is taken from a recent outlook from the International Energy Agency. You can see with a breakdown of the energy used for the different types of energy carriers. The target for the first years is to stabilize the demand of energy from the transport sector, and then gradually increase the share of biofuels and electricity, while at the same time reduce the share for conventional diesel and conventional gasoline. We can do some considerations here. First of all, we can see that the growth of electricity and biofuels go nearly together. The two are not to be thought to be in competition each other, also because you have some applications like shipping, aviation, or heavy road transport, for which the use of batteries is perhaps not the most convenient option. And we can also see that the decarbonization is hard to occur, because you have a share of conventional diesel which is still there. So you have a reduction, but that's not dramatic or compared to other fossil fuel use that you have in similar 2 degrees scenarios. Because the alternatives that we have to fossil fuels in the transport system are just a few, mostly electricity, biofuels, and maybe hydrogen. For the energy sector, you have other options that are available. And we can now have a focus a bit on biofuels and electricity. With biofuels first, when we speak about biofuels, we refer to different types of biofuels. This is, again, a picture taken from the outlook of the International Energy Agency, where we can see that advanced biodiesel and biojet fuel are likely to flood the market after 2025 or so, with a large upscaling in terms of biofuel production. This is, of course, connected to something we have already discussed this morning, which is the mobilization of a huge quantities of bioresources, which is something that has to be taken into account. And when you have policies that implement biofuels, we need to be sure that they go together with appropriate policies connected bioresource supply, sustainable land management, in order to prevent possible conflicts with other land-derived products, food security, and possible trade-offs with ecosystem services. And in terms of the transitions that can happen in the biomass energy use under a climate change mitigation policy that is consistent with the 2-degree target, we can see that the role of biomass is key. We start from a situation in 2010, here on the left-hand side, where we use something like 50 exajoule of biomass for energy uses, and the majority of it is used in the residential sector, in stationary applications. In 2050, this is just one of the studies. There are others available, but in general, the insights are very similar. There will be a growing demand for using biomass to produce transportation biofuels, which is becoming the most cost-efficient option. And here, and with a strong decline of biomass use in residential sector, in stationary application. So this is a large transition in the utilization pattern of biomass resources. And another consideration here that we can do is the fact that we are using biomass to produce transportation biofuels with an efficiency of something 40 or 50%. With a lot of carbon that goes lost, vented to the atmosphere in the form of CO2. And this is, of course, something that is becoming attractive to have a carbon capture and storage associated with biofuel production, so that you can have 2 birds with 1 stone, if you wish. You can produce transportation biofuels, for which you have high demand from the transport sector, and at the same time produce negative emissions, which are essential to achieve low temperature stabilization target. Concerning the transitions in the electricity sector, I take here one study which is trying to understand what are the implications in Europe for different levels of electrification in the transport sector, which goes from 20% up to 80% in 2050. We can see that in terms of CO2 emission reductions, they can be quite substantial relative to a baseline case here, which is a reference development, which is the black line. Emissions can be reduced up to 60% by 2050. And if you consider the additional emissions from the energy sector to produce the additional demand for electricity from electric vehicles, you see that this is still, you lose some of the benefits, but not dramatic, also because this is supposed to develop the energy system in parallel with a green transition where more than 50% of the additional power demand can be supplied by non-renewable sources. So if you want to make an analogy between biofuels and electric cars, we can say that for biofuels, it is important to have cross-sectoral policies that cover land management and bioresource mobilization. For electric cars, it is important to have proper policies and instruments that can favor the development of the energy system on the background, which is key. And we see one example of the importance of the background energy system in this slide, which is produced by my colleagues at NTNU, where we can see a comparison between the life cycle emissions of electric cars against conventional cars. If you use fossil fuels like natural gas or coal to run the car and produce the batteries, then you hardly have some savings in terms of carbon, you actually can have higher emissions. If, on the other hand, you use clean electricity in the background, like wind power or hydropower, then you can have important savings. I spent the last minute of my presentation to discuss about the last point, activity, which is connected to behavior, to lifestyle, which is sometimes overlooked in the different discussions that we have. It was already observed in the 19th century by Sir William Jevons that more efficient use of coal will lead to an increase in the utilization of coal. Efficiency leads to substitution of energy for labor and increased outcome. What are we talking about? Is the rebound effect. What is the rebound effect? For those of you who are not familiar, if I have a car which is more fuel efficient, I have incentives, I have right policies, that I have a car which is less polluting, then on the first instance, I save energy. But I have a direct rebound effect because at the same time, I have lower cost to run my car and I'm inclined to use my car more often and drive farther distances, which requires some energy. So we go into psychology here, as you can see. And I may also have an indirect rebound effect because I pay lower bills, and perhaps by the end of the year, I can afford that trip to Maldives that me and my wife have been dreaming of for all my life. So which requires energy. So rebound effect is something that has to be taken into account, which calls for an additional sector for which we need to have policies, which is our behavior, is lifestyle, for which governance is needed. This is an example of how much we can compromise in terms of greenhouse gas savings from the rebound effect, which can be up to 50% if you consider that an electric car can make me spare money, and then I spend this money on other expenditure which have a carbon footprint. At the end, what we have is that the achieved greenhouse gas savings are the expected savings that I have from an engineering and accounting point of view minus the rebound effect. So this is just an example to call for the importance to have consistent and harmonized policies across the different sectors of our economy. I think that's all for my presentation, and I thank you for your attention.
Great. Sit down, make yourself comfortable. And the rebound effect was wonderful, wasn't it? That's why Diet Coke doesn't work, because you just go out and eat another cream cake, don't you? Who would like to put the first question? One of our expert group. Who's going to put the first question to okay, thank you. Someone we haven't heard from yet. Magnus Korpos.
Hello, and thanks a lot for a very good presentation. I have just a short question, or your opinion about about electric vehicles. I'm just wondering, what do you consider as the kind of main environmental or resource-wise drawbacks of electric vehicles? We know their benefits, but there's also considerations about the amount of rare earth materials needed and the environmental aspects of that. So I'm just curious about your, if you have any insights from your colleagues' recent research about that.
Yes, this is a very good point, and I think a battery manufacturer has an influence on this, and the competition for mining and earth materials are something that has to be taken into account, especially under a large scale, upscale that is needed to achieve the numbers that are needed for climate change mitigation targets. And I know that this is a research field which is getting increasing interest worldwide. So it's something that is, I think, important to be taken into account.
Question from the audience? Yes, let's hear from the audience.
Yes, so Stian again, PhD student. Follow-up question to Magnus's question. One of your slides had this end of life treatment. And then I was thinking about the batteries in these electric vehicles and how, is there any sort of research, recent research on how you treat the batteries in the end, recycling or processing them?
Yeah, I think there are some options that are taken into consideration, as we can see here from okay, disappeared. But from a greenhouse gas point of view, it's something that has a low or little influence. It is perhaps becoming important in the context of circular economy and availability of resources and materials. It's becoming perhaps an attractive option to recycle elements in the batteries. And also this is an active field of research in itself. And this is, of course, something that can better facilitate the transition of electric cars in the market.
We have with us here at the back, who's unable to squeeze himself into the front, none other than Jay Edmonds. And I think he has a question about behavioral change, or a comment, possibly.
So I thought that was an excellent presentation, and I think you did a very nice job of pointing to the fact that we're in a state of flux in the transportation sector where we could be going bioenergy, we could be going electrification, we could be going some combination of that. In addition, there's some other things going on simultaneously that I wonder if you'd like to comment on. For example, the interconnectedness of vehicles, the control systems that have become important to the transportation sector in a way that we haven't seen in the past. And if you would just comment a little bit on how you see those fitting into this transition period.
Thank you, Jay.
I think this is a very good point. I mean, here we are speaking about scenarios that goes up to 2050, so it's difficult to predict how technology will develop. But I think something important that can help us to achieve the targets that we have is to find instruments that can rethink the mobility concept at a general level, right? To have this networking and approaches that can actually act on the initial demand that we have for transportations. And those types that you mentioned before are, of course, something that can help us to achieve this transition.